didn't get around to that. Who didn't get homework back? Name. Something odd happened with yours. You got forfeited.
Oh.
I don't know why it didn't download, but I did grade it.
Oh, okay.
It didn't make it into the what got printed out. Anyone else? Okay, cool. Any questions? Awesome. So today we're going to talk about exceptions. Oh, we're also going to do FCQs today. We'll do that at the end. Any questions on the chapter? Cool. So we've actually seen exceptions already. These are runtime errors. When we run our program, something unexpected happens, it explodes, and big red output comes out. Those are exceptions that Java has automatically built into the framework. And they're basically responses to unexpected circumstances. We specify an array, an index into an array that is outside of what can actually be indexed in the array. We get an array index out of bounds exception. That's something unexpected. At compile time, there's no way of knowing whether a particular index is going to be valid. So it might compile fine, but it runs. That index is invalid, it blows up. We've also seen things like null pointer exception. That's when you try to call a method on a variable that isn't pointing to anything yet. It hasn't been given a value, so there's no object there to handle the method call. But up until this point, we've kind of been at the mercy of the Java runtime. If Java wants to throw an exception, it's going to throw an exception. There's nothing we can do about it. Our program breaks, it stops executing, we're done. So in order to avoid causing exceptions, we're limited to checking for error conditions and handling them right up front. So basically, we have to know all the possibilities that might happen in our code and use if statements to check for those conditions, and if those conditions exist, we do something hopefully intelligent. That works well in a lot of circumstances, but sometimes there are things that you just can't detect. There are tons of possibilities. You can't check for every single one of them. And there are also some conditions where when you check the condition, the error condition might not exist. A few lines of code later, the error condition might exist. Take, for example, network communication. Think about it in terms of you click the little icon on the what's it called in Windows? Taskbar. That little area at the bottom right-hand corner of the screen. The only thing in Windows that hasn't moved across multiple generations. You click that little icon and it says, you have internet connection. You pull up a web browser, hopefully not Internet Explorer, and type in a web address and it says this web page cannot be found. You are not connected to the internet. That's the sort of situation we're talking about. So you can check your internet connection all day long, but between when you check the internet connection and when you actually try to go to the page, the connection could drop. This is especially the case on things like mobile devices, where internet connectivity is subject to what butterflies are between you and the cell tower. So exceptions provide a slightly different order to checking for error conditions. So instead of checking for an error condition right up front and then hoping that nothing has changed by the time you actually try to use that assumption, exceptions reverse that. So you try to do something, and this is actually where some of the keywords come from. You try to do something, and if that blows up and fails completely, you do something else. So you assume that everything's fine and try to do whatever you're trying to do. So try to go to a web page, assuming that you have an internet connection. And if that fails, then you can, take out your phone and see if cell network is up. Try to do some alternate strategy. So it's kind of the concept of, I guess, where these came from was computers are going to break. Bad things are going to happen. Rather than trying to check for every bad thing that could possibly happen, just try to do what we're doing, assuming that nothing bad is going to happen, and handle it when it does happen. So it gives us, I guess, some benefits and some irritations as well. The benefits are that we don't have to have extensive error checking. And even more of a benefit is that we don't have to know what every possible error condition is going to be. We don't have to anticipate everything, which is nice. If we did have to anticipate everything, our methods, even if the doing part of the method was maybe 3 lines of code, our error checking part would be 50 times that. So with exceptions, we can have 3 lines of code that actually does something, and exceptions that amount to maybe 2 or 3 times that to handle when things go wrong. I guess at this point I would normally do a demonstration of how to use this particular construct. I don't particularly care for exceptions, and I feel almost like a contrived example would not be doing justice to exceptions. But I'll see what I can put together. I'll use the book's contrived example, which causes a divide by 0 exception. This is on page 660, by the way. I'm actually going to do a slightly abridged version. Okay, the listing on page 660 has some error checking using if statements in there to test if milk count is, well, to test if milk count is less than 1, then it does something different. Otherwise, it continues to do the actual calculation. I left that out because I want to cause this exception. So save this program, compile it, and fix my spelling. Now we'll run it. So if I have 4 donuts and 2 glasses of milk, I have 2 donuts for each glass of milk. However, if I say 4 donuts, 0 glasses of milk, what's going to happen? It's going to explode. Division by 0. We can also cause other sorts of exceptions. Let's say somebody already ate half a donut, so I only have 3.5. That explodes as well. So, just with this simple program, and just by kind of intentionally trying to break the program, we came up with 2 exceptions. So, let's see if we can figure out a way to handle these exceptions and make the program a little bit more robust. So, a user who has absolutely no idea how I wrote this program can use it and it won't break. So let's handle the division by 0 first. One approach to that could be what the book does, which doesn't use exceptions. It just basically statically checks to see if the number of glasses of milk is 1 or greater, something that we can divide by, and if it's not 1 or greater, then it says you don't have any milk. Go get some milk. But let's assume that we're not entirely sure that's the only error condition that exists. We're pretty sure that whatever error condition might exist is something that would cause I scrolled past it now. An arithmetic exception. So division by 0, maybe for some reason, if someone enters an infinite int, which isn't possible, but somehow enters infinity, that doesn't make any sense either. That would probably cause something to blow up. So what we're actually going to do is say, basically try to do these statements, and the keyword is in fact try. try is followed by a block of statements to attempt to do. And Java will execute statement by statement within that try block, following the usual rules of sequence selection and iteration, until an exception occurs. If an exception occurs, that statement will not get executed. I will say not get executed fully. Java executes as far as it possibly can. As soon as that exception happens, it stops executing that block and jumps to what we're about to write, which is our exception handler. So it is possible that half of the block will get executed, an exception will happen, and the second half does not get executed. So it's a good way to kind of make use of dependencies. So, for instance, we haven't talked about files yet. We're going to talk about that next class. But say you try to open a file, that breaks horribly. But if you successfully open a file and you want to read something from the file, inside your try block you can have the file opening code and then the file reading code. If it fails to open the file, it will break horribly. It will refuse to execute the rest of that block and do some exception handling. If you open the file successfully, but for whatever reason can't read from the file, that will break and it will jump to the same exception handler. And when we actually use files, we'll see that in action. So, how do we handle exceptions? We handle exceptions using the catch clause of this try-catch construct. I need to keep my braces consistent. Well, I guess they were consistent with this file, but they're not consistent with Java convention. So there we go. So the basic structure of the try-catch construct is try some block, or it follows the same rules as if statements and loops and that sort of thing, where if the body of your block is only one statement, you can omit the curly braces. In general, you'll have multiple statements in both of these sections, so I can't remember the last time I saw a try-catch structure without curly braces. So try followed by a block of statements to attempt to execute, then the keyword catch, and then inside parentheses you specify a type of exception. In Java, all of them end with the word exception, and an identifier. This identifier allows you to get information about the particular exception that occurred within this next block. And just like everything in Java is an object and automatically inherits from object. And we can create our own inheritance hierarchies beyond that. Every exception in Java has to inherit from exception. So we'll actually start creating our own exceptions. Sneak peek, they're basically just classes that inherit from the class exception, or something that inherits from it. The only type that is valid inside these parentheses is either exception or something that inherits from the exception. The highest level thing is exception. So the way this is written right now, any exception that occurs will get caught by this block. However, if I want to be specific about it, I know that an arithmetic exception might occur. I definitely want to test for that. Especially for debugging purposes, I don't want to catch every possible exception, because there might be exceptions that I don't know will exist, and I don't want to handle them potentially the wrong way until I know that I've covered every possible exception that can occur. I don't really want to just catch a blanket any exception, so that I can potentially print out a specific error message if there's a divide by 0. If somehow a null pointer gets in there, I might want to print out a different error message. And I'll get to that in just a second. So instead of exception here, I know that arithmetic exception will occur. So arithmetic exception. And then inside this block, I put statements that should execute if this exception does occur. So no ilk, no milk. I think that's essentially what the book says. So this is a very short and essentially contrived catch block. So it only has one statement in it. But now, if we compile and run this program, we can say 4 donuts, 0 glasses of milk, and it doesn't explode. It nicely tells us, you don't have any milk, go get some milk. Questions?
Is there a way to do it with fraction? Yeah, so it's 2.5 donuts.
Right, I'm going to get to that in a minute. So, I mentioned before that it's possible that multiple different types of exceptions could get thrown within the same statement or set of statements, basically within the same try block. And we're not limited to one catch clause. We can have multiple catch clauses to catch multiple different types of exceptions and thus handle the different types of exceptions differently. In this case, there's no way that we're not dealing with any reference type, so there's no way we can get a null pointer exception. But if I wanted to be extra safe, I can do something like this, and somehow there was a null pointer. And that's valid. And you can have as many of these as you want. So now, let's think about this inheritance hierarchy thing. This is kind of like a switch statement. And I say kind of because it's very kind of. A switch statement, as you recall, you have one test value and then a bunch of other cases that it might match up to. And assuming you don't specify the same case multiple times, there is only one possible option. With the inheritance hierarchy of exceptions, that's not necessarily the case. If I had catch exception E later on down here, properly capitalized, and an arithmetic exception gets thrown, there are two cases here that match. An arithmetic exception is an arithmetic exception. That's a no-brainer. An arithmetic exception is also an exception because of this tree of exceptions, this inheritance hierarchy. So the question is, which handler actually handles an arithmetic exception? Any guesses? You guys who had Visual Basic don't get to answer this because it's the same in Visual Basic. We have one guess. The guess is that both get executed. Any other guesses? We might as well enumerate all the possibilities. One possibility is that it doesn't compile. One possibility is that there's a runtime error. One possibility is that the more general exception gets executed. Another possibility is that the more specific one gets executed. Another possibility is that the first one that matches get executed. And the last possibility is that both of them get executed. So let's find out. Okay, so it compiles, so it's not that one. 4 and 0. It ran fine, so it doesn't cause a runtime error. So we've narrowed it down to two possibilities. One possibility is that it's the narrower of the two, and one possibility is that it's the first one that matches. I'll hold off on the suspense and say that it's the first one that matches. So if we had the exception, the general exception catch first, any exception would get handled by this. And everything else is superfluous because everything else inherits from exception. And we can demonstrate this as well. Java.lang.arithmetic exception has already been caught. Java is smart enough to say that arithmetic exception is further down the inheritance hierarchy than exception is. So that block is superfluous, doesn't need to be there, is never ever going to get executed. So it is sometimes handy to have kind of a catch-all. This is kind of like the default in a switch. And have some sort of debugging output there. So an exception happened that I didn't account for. That way, I can specifically catch each exception that I know might happen, but I still have something that will print out some information when an exception occurs that I wasn't expecting, that I haven't accounted for yet. And then I can go back and specifically catch that exception and try to do something intelligent in that situation. Questions?
Only catch exceptions that happen in whatever you put in the try block or whatever.
Yes.
In the entire program.
So the try block and the catch clauses are tied together.
Okay.
So the only thing, if an exception happens outside of the try block, the program still blows up.
Okay.
So this, I would actually consider that an advantage. Because it limits, it makes it easier to debug, for one. It narrows down the area of code where something happens. So you can specifically test if this piece of code throws an exception, then I know I can take this specific action. And one instance is, let's say I have a method that is opening up two files, one that I'm reading from and one that I'm writing to. If I fail to open the one that I'm reading from, I really can't do anything else. I'm done. So I want to take one set of actions. So I can put that in its own try block with its own catch clauses. That will end the program, for instance. However, if I can't open the file that I want to write to, maybe that's not a failure condition. Maybe I just want to write to standard output instead or something like that. So take two different actions based on what statement it was that actually broke. Any other questions? Cool. So the last thing with the structure of the try-catch block is something called finally. And usually the official explanation of the finally block is that it contains statements that should be executed regardless of whether or not an exception occurred in the try block. And because that's an absolutely terrible explanation, the necessary question is, why can't I just put those statements after the try-catch block? In a case like this, you can. There's really no reason to have a finally block. So I can do that. There's nothing preventing me from having more statements after the whole try-catch block. However, I cannot, from that statement, line 29, I cannot access any variable that was declared inside the try block. So it's not an issue of where I can and can't have statements. It's an issue of scope. So this donuts per glass on line 14 is declared inside the try block. So on line 29, I cannot say that. I cannot use donuts per glass outside of the try-catch mess. And it says cannot find symbol. I don't know what this is. It is not in scope. If I want to print out the value of donuts per glass, obviously it won't make sense if an exception occurred. But if I want to print out the value of donuts per glass, regardless of what happened, I would have to put that in the finally. So let's steal this. Did I spell it wrong?
You should run into the same problem if you divide it by 0. When you try to do it again.
If the computation breaks on line 14, it shouldn't change the value of donuts per glass. Donuts per glass should still exist. It just doesn't have a known value. Java appears to not behave like every other language that supports exceptions. Okay. About a third of the way down on page 694, the book talks about why Java has a finally block that doesn't act like any other language's finally block. And the reason for that is if an exception... So I mentioned that the finally block gets executed regardless of whether or not an exception is thrown in the try. So this means that even if you don't catch the exception, the finally block will still execute. So it doesn't have the same scope as the try block, which is kind of irritating. So in order to actually use donuts per glass there, I would need to do that. Yes, might not have been initialized. But if something else happened that I didn't account for, assuming I didn't have this catch exception E here, because that will account for everything. If an exception gets thrown and I don't catch it here, it will get bubbled up to the next method, the method that called the main method. And that's actually when we do absolutely no catching of exceptions, when we get the red output, that's actually what's happening. An exception is happening somewhere in our program. We don't catch it. It goes up to the next method. If we're in the main method, it bubbles up to the Java runtime's invocation of our main method. And eventually, somewhere up the line, Java, in essence, handles the exception. And its default behavior is to print out the name of the exception and to print out a stack trace. So it tells us exactly where the exception occurred. And there are actually some properties and methods of exceptions, because exception is a class. Exceptions that get thrown are objects. They have data stored in them that is, there's a message, there's the type of the exception, and the stack trace. So we can actually say, let's not do it there, that won't ever get called. Let's do it here. I don't remember what the method is called. I think it's called get stack trace. I was right. This is the message, divide by 0, which when it exploded, that was it said this type of exception occurred, and then some text. That was the message. And here, this is the result of printing out the value of e.getStackTrace. Not very useful output, but it's an array of something called stack trace elements, which basically, if we were to iterate through that and print everything out, it should give us something intelligent. So all of our stack trace elements. It looks like when Dr. Java handles this, it actually picks one of these and stops there. It doesn't print out this entire mess, because a lot of this is internal to Dr. Java. Dr. Java is written in Java, So it, in essence, invokes the main method just like any other normal Java call. So when an exception occurs, the stack trace includes all of Dr. Java plus all of your program. So yeah, in order to actually be helpful, it doesn't print out all of the internal Dr. Java stuff, because the bug is most likely not in Dr. Java. It is most likely in your code. Right. So that's handling exceptions. Now let's talk about throwing exceptions. So these are when we find error conditions, but we don't know how to handle them. We test for error conditions using an if statement or something like that, but it's something that wouldn't normally cause Java to break. So it's not divide by zero exception or array index out of bounds exception or null pointer exception or something like that. But it's... Wait, hang on. I was going to deal with the decimal issue. So let's deal with the decimal issue first. So without using exceptions, what are some ways we can handle that? Because I'm using nextInt, if I type in 3.5 for a number of donuts or something like that, it explodes. And I really don't get any control over that because all of that is handled inside nextInt. So if I type in a decimal, it will explode. So my options are really limited to not using nextInt. I can use next double, and then if it somehow doesn't convert nicely to an int, do some error handling there. I could also take it in as a string, because any token that I type at the keyboard is a string. I can interpret it as a string. Then use something like, I've talked about integer.parseInt here, right? So we could use that or double.parseDouble. But that would also create an exception. Actually, that would cause exactly the same exception if it could not be interpreted as an int or a double. And that's actually how nextInt operates under the hood. It calls the next method on the scanner, and then it tries to convert it into the appropriate type using integer.parseInt or double.parseDouble. There are also methods on integer and double that is something called try-parse, which if it fails to parse, it returns a Boolean false. But all of those get more complicated, and it's a lot easier if we just use an exception. So we can do something like that, and does anyone remember what the type of the exception was? Yes. I have the return in there just so that it ends the main method. I could just as easily do system.exit, but returning from the main method is a little bit cleaner and nicer. Cannot find symbol. So let's figure out where that is. Oh yes, the scope issue again. I'm kind of curious, if I don't initialize that, will it realize that if it does not get initialized, it will necessarily return, so by the time that statement executes, it has to have been initialized? My guess is no. Oh! Java got smarter. Three and a half donuts. You need to enter an integer. Success. Okay. Throwing exceptions. That's how we throw exceptions. Of course, for right now, there's no such thing as an out-of-milk exception. So we can't throw one because we don't have one. So for now, let's just throw an exception, a generic exception. And exception has a constructor that takes a string as an argument. That string becomes the message. So we'll say out of milk. Right. So most of this should look familiar. The new exception part looks very much like we're creating an instance of an object, which is, in fact, the case. The only difference is this throw keyword. And the throw keyword is basically, it's different from everything else that we've seen so far, but maybe not return. It's closely related to return. It basically says, stop everything you're doing and deal with this right now. It's kind of an executive order. And the syntax is the throw keyword followed by an instance of an exception. Doesn't need to be an object of the exception class. It just needs to be something that is an exception. Which means that the syntax as I have it here is not the only possible syntax. I don't have to have throw and new right next to each other. I can create the exception somewhere else. And I've actually done this before. I can create an instance of an exception class somewhere else and then just throw that instance in my throw statement. So I can create one exception with some general message about what's going on. And then if I hit certain error conditions, I can throw that instance. So create one instance and then throw it from multiple different places. This is the usual syntax, though, the way you'll usually see it. You'll create an exception and throw it in the same statement, because unless you're throwing an exception, most of the time you don't need to actually create an instance of an exception class. So here, okay, Java has gotten really irritating recently, and it wants programmers to be really explicit about when exceptions are being thrown. So there is this kind of extra declaration. We've seen extra declarations on classes with extends and implements. With methods, there is an extended declaration called throws, and then we give it the type of exceptions that it might throw. And the exact error message that the Java compiler gave us was must be caught or declared to be thrown. So we had two options. We could either do this throws exception syntax, or we could actually wrap it in a try-catch block. In a minute, I'm going to talk about why that's bad, but for now, yes, that is something you can do. So now run and 4 donuts, and I have 1 glass of milk, and we throw an exception that we don't actually catch, that is out of milk. Questions? So I mentioned that, or when I first put that exception in, I wanted to write out of milk exception. Throw new out of milk exception. And custom exceptions are useful in a variety of different cases. One is that by their name, they are more specific and particular to your program than just general exception, arithmetic exception, array index out of bounds exception, null pointer exception. The Java framework, when you start writing larger programs, actually has very limited names of exceptions. They cover a lot of cases, but it's mostly things that might happen through using Java, not necessarily through using your program. So you'll want to create custom exceptions. And another reason for creating custom exceptions, sorry, insect in the building, is if you want to store some extra data in exception. Exception by itself only stores things like a message, a stack trace, things that are common to every exception. In the case of an out of milk exception, I might want to store how much milk I actually have right now. It might be useful in whatever is handling this exception. I might have one handler, or in one part of my code, I might have one handler that says, yes, I'm out of milk, but I still have 2 glasses left. That's okay. Another part of my code might say, something through an out of milk exception, that's enough for me to want to go buy more milk. If I'm using this in a restaurant application, 2 glasses of milk is beyond out of milk. You know, if I have fewer than 10 glasses of milk, I need to stock up on milk. But if I'm just me living in my apartment, 2 glasses of milk will last me for 4 days or so. So it's not that urgent that I go out and get some more milk. So let's say that we have an additional argument here that is the number of glasses of milk left. So let's create that new exception type. And it starts off just like any other class declaration. The only difference is that it must inherit from exception or something else that inherits from exception. So somewhere along its inheritance tree, exception must be in there. And really, that's all that we need to have an exception. With just that, really one line of code, we can now use out of milk exception as its own exception. of course, the way we're using it, we do specify something to a constructor that at present does not exist. So we do need to implement a little bit more. But aside from that, this is ready to go, ready to be thrown. And it's a convention that all classes that inherit from exception end with exception. So I shouldn't call this out of milk issue or anything like that. I should call this out of milk exception. Just to be explicit that it is actually an exception. And now it shows the type as out of milk exception. There is no message because I did not specify a message. If we wanted to, we can override get message and have it return some string that says you only have number of classes and we get an appropriate message back. A case where creating the instance of the exception class before it actually gets thrown is something like this. So we can say create the instance of the class. Eventually we'll throw that instance, but in between I think this will work. Let's make use of this. Super.get message. So we're calling the implementation from the parent class of get message from the child class's implementation of get message. Right. Set message does not exist. is actually probably a good thing, because that means that exception handlers can't change it. But we can do something like this and change our constructor to take that message and call super message, and then everything will work out the way we wanted it to. Questions about exceptions? So we talked about handling exceptions, we talked about throwing exceptions, and we talked about creating your own types of exceptions that you can then throw. So there are also a group of classes that are very similar to exceptions, but different in very important ways. There are things called errors, exceptions and errors are both implement the throwable interface. They are both things that can be, I believe, thrown using the throw keyword. The difference is that exceptions can be handled using try and catch. Errors cannot. Errors are things that are unrecoverable, basically. So while you can create subclasses of errors, they're generally lower level things that Java would cause that would make your program explode, and you can't do anything about it. The most common one that I've seen anyway is out of memory error, which basically means Java is using up too much memory and there's really nothing it can do. The program dies. There's no way to recover from that. It can't really clean up memory because it doesn't know what memory to clean up. You're probably using more than you should, which it's not going to make a decision about which references it can kill and which references it should keep around. So errors cause your program to die hard, and there's nothing you can do about it. Okay, so whenever I talk about exceptions, I pull up this handout, which I actually wrote for the Visual Basic class last semester. So you guys have seen this. I really should rewrite this to have Java examples, but it still has Visual Basic examples. And it is available if you go to the course website and take off the last piece, the piece that's specific to this class, and look in the list of classes I've taught for the Visual Basic class, it's somewhere in there. Or you can copy down the URL. And it basically talks about the motivation that I talked about at the beginning of class, how you would normally handle errors, how you can't enumerate every possible error, so why exceptions make error handling easier. Again, all Visual Basic examples. How you handle exceptions, which most of this is different because all of this talks about Visual Basic. Throwing exceptions, we still have that in Java. And then best practices, which is really the important part of this document. There are good ways to use exceptions and there are bad ways to use exceptions. And I've seen people use exceptions both ways. And this is also something that people have debate over. Some people think that one thing to do with exceptions is a good thing, and other people think that is a bad thing. I tend to be on one of the extremes. If there's an argument that could be made for why using exceptions a certain way is a bad thing, I probably think it's a bad way. But here are just a couple. First thing is the length of code to try and catch. I mentioned, kind of in passing, that try statements should be very specific to a statement that might actually cause an exception. So if there's a group of statements that might all cause the same exception, it's redundant to have a try around one statement that catches a particular exception with a particular message, and then have this exact same try-catch block around the next statement to catch the exact same exception and print out the exact same message, and do that 3 or 4 times. Those statements are closely related. They might all break in exactly the same way. Put them all in the same try block with one catch clause. That makes sense. However, the example that I give here is that you have 2 statements that throw 2 completely different exceptions, both inside the try statement, inside the try block, with 2 different catch blocks. That's bad. Things that are independent and might cause independent exceptions should be treated independently. The next best practice is throw or handle. Pick one. Don't do both. The book talks about rethrowing an exception. You can read that section if you want to. I believe that it is bad. So if you are going to have a try-catch block and catch an exception, you should deal with that exception right there. You shouldn't say, I know that this exception might occur. Let me catch this exception. Oh, wait a minute. I don't know how to deal with it. Let's throw it again. That's bad. On the other hand, if there's an error condition that you know might happen, but at that point in your code, either it's inappropriate to deal with that error condition, or you really have no idea how to deal with it, then it's okay to throw an exception and have it bubble up to the method that called the method you're in. But don't do both in the same method. And certainly don't have this case where you throw an exception and immediately catch it. Right, throwing an exception from a catch block is the other option. Empty catch blocks. I have seen this all over tons of code. This is bad. This is very, very bad. It is very hard to debug code that has empty catch blocks. Think about what that actually does. There, you have a piece of code that might break. You wrap that in a try block with a catch clause that does absolutely nothing. So when something actually breaks, you have absolutely no indication that something broke. a few years ago, I was working at a startup back when I still lived in New Jersey. And it was me and another programmer. The other programmer always did this, always built, Visual Studio makes it very easy to wrap something in a try block and not put anything in the catch. I think it's, when something breaks in Visual Studio, it pops up a little box that says, oh no, something broke. One of the options there is wrap this statement in a exception handler. And it doesn't know what you want to do in a catch block, so it just leaves it blank. So our code base was littered with statements surrounded with try blocks with empty catch blocks. And I spent several days one time trying to track down an error where everything was working fine, but something wasn't getting written to the database, ever. And eventually I tracked it down to exactly one of these. It was something that was a spelling mistake or something like that. So it didn't cause a compiler error, but it was trying to write something to a table that didn't exist, which was failing. And that statement would fail, cause a catch block to execute that had absolutely nothing in it, but that didn't affect anything else in the code, so everything else worked fine. It just never got written to the database. So ever since then, I believe that empty catch blocks are very, very bad. I have used one before, and this is more a factor of why I believe exceptions can be bad, rather than just bad programming. But if there is a case where you need to put an empty catch block, make sure you comment that. I think my instance was I wanted to try to write something to a file, kind of like what I described with the two files in Jude, try catch blocks. If I can't write to the output file, I should try and maybe it'll throw an exception. If it does throw an exception, that's not necessarily bad. That just means I can't write to the file. So make sure you comment when you deviate from good programming. Rules are made to be broken sometimes, but comment when you break it. When you break those rules. Questions on exceptions? Cool. So rather than a break today, let's do FCQs. Let me stop the recording first.